So let's try the platformer 2D demo for God 4. So I have a controller plug-in, but let's try it first with the mouse and keyboard. Oh, this is definitely more involved. There's some sort of physics for the bullets. Definitely this is more of a complete game. Well, not really complete, but okay, I have a little jump too. Oh, that's it. Well, hey, that's fine. No parallax throwing. I'm noticing a few things here and there. Oh wait, no, yeah, there's parallax. It's just very subtle. It's just very subtle. Okay. Let's try it with the controller to see how it handles input. So no joystick input. Oh wait, I don't have the controller plug-in. Oh yeah, it uses the get axis method of moving, so you can modulate how fast it runs. The D-pad's input are a bit messed up also, so that's something we should fix real quick. I wonder what kind of controller they were using that messes up the... Now the buttons are right, but the D-pad... See? Move left is D-pad right for some reason. It's supposed to be D-pad left. And then move right. That's so weird to me that is so different. Because even in the options, you can see that it's not using the standard way of moving left and right. Shoot, jump, W. Yeah, this one is... So move left P1. Exactly. I also need to change this one and move right. So there are multiple players. What about this one? Again, same thing. Let's see if there's a pause button here. D-pad up. That's the pause button. It should be. Button 6. Start. So it is weird that most of the demos have weird joystick controllers. They are not standard. Or maybe, maybe, well, actually, that makes me think that maybe I downloaded the wrong demo. Okay, it feels good. I'm not really sure about the double jump because it's so solid. But it's more like a dash up than a double jump. Okay. How do I change it to two player? Oh, so that's how the two player mode works. Let me change it back. Let me get damage. I cannot get damage. There is no damage. There is no damage in the game. Well, there's damage for the enemies. Still, all the basic stuff is here. So all the basic stuff is here. This is definitely a more involved, more detailed game than the previous few games. So let's see, what do we have here? So we have the game. It was only one level. Easy zone scene. So we're just adding the player to the level scene. Interlaced interface layer. And it's just a pause menu. Yeah. Okay. Okay. Full viewport. Enable. So it's a pause menu. Okay, so we can just see the different scenes. And the pause menu scene. All control nodes. Now this is more of a variety. Oh my. Lots of sprites. So when you have a very detailed game, it can get crazy. I mean, like, how do you do this? Do you put every flower independently? I guess. Hey, it's all about, being an artist and little by little painting the details. grass, flowers, coins. Let's see the flower scene. None of them are a scene, but of course, none of the grass is a scene, so they are merely visual. However, coins are its own scene that are being instanced with its own. Let's open it. With its own script. The platforms. So the platforms are also its own scene. And the enemies, of course, no surprises here. The trees, of course, merely visual sprites. Okay. So there's more functionality on other stuff. So let's check the coin. We're going to move the player here. We're going to check them later. But let's check the level. And let's check the coins. And see how they work. So it's just an animated sprite. Well, not a sprite to the with animations, of course. Animation player. Spinning. Let's see this animation. That's all the animation. Hey, that's fine. Let's see that. So it applies the spin once instead of looping it, and also seems to change the alpha, right? So it applies the spin animation and also the position, of course. So it's a very simple animation. The collision shape and the pickup sound. So let's check the script. Class name. Coin. Stance. Area to the. So it's an area to the. So it's an area to the node. Already variable. Animation player, of course, you want to start the animation player. Well, you want the script to know what the animation player is. I'm pretty sure that the spinning one, it starts when you load, because it's not mentioned here, so it just starts by itself. But in order to play the animation for picking it up, we need to get the animation player. So the coin node script needs to get the animation player and then play the picked animation if on body enter, body node 2D. This is for the player, but it's not. It's not really checking for the player. Yes, it is checking for the player actually. So it is shaking for the player. But I wonder why I need to check the enemy too. Because the enemy, of course, is a type enemy. What do you mean type enemy? Because we're calling the we're calling the class enemy, of course, class player. Both of them are character body 2D. So both of them are character body 2D. So the coin is going to look for a body, no 2D. Body as player, of course. Then we checks for the player. Emit. So there is a signal. I see. So there is a signal here. Ah, that makes sense. Oh my god. Now I was confused. Now that there's a signal, everything is explained because I was questioning myself. Why not check if it's a player here? Like, if no to leave, if no to leave, if no to leave equals player, something like that. Player is its own class, so we could do something like this, and then you know. Well, we cannot do this because, but we don't need this because the signal is being sent here and it's already checking for a player. So we'll check the player later to see how it all comes together. But yeah, let's just leave the coin for now. There's the platform. Now the platform had a script on level. Did it? No, it didn't have a script, so it's just a collection of nodes. So it's just the visual aspect of it with a collision shape. That's very simple, so there is not much. I thought that maybe there will be a script with movement and stuff like that, but no, there's nothing here. I didn't pay much attention when I opened the the scene. Now the enemy we know is very involved because we already took a small look, a small peek at the script, pretty much almost as complicated as the player. Which we haven't looked. Maybe we should start with the player script, but that's so complicated. Man, some of these scripts are so complicated. So I think this one is simpler. Platform detector, floor detector. So these are new nodes. Well, no, these are not new nodes. There were raycast. There were raycasts in Go 3.5. If we add a death function to the player, we could add this same explosion, copy paste it, and add it to the player. And maybe change the color. Because it is, there's no reason why there's not a death animation for the player. Like, he should die. So, enemy. So, let's take a look. Let's take a look. So it has two states, and of course the walk speed, and walking by default, the variable is using the so it can fall. Interesting that it can fall. Yep, it can fall. There's gravity applied to it, so it can fall. And that makes sense because, well, that's why it has all these detectors. So we set the different variables. So let's see how the physics process works. And if state equal state walking, so if the state is walking, then velocity is 0. An approximation function here. The velocity x is walk speed, so it's never 0. It should never be 0, the speed. Then there's the gravity calculation here. If not floor, detector left. Okay, so it uses the floor detector. So let's see how they look. So it has 3 detectors, one for the one seems to be just for the platform, and one for the right, and one for the left. And it seems that this is what it uses to decide where it's going to walk, with direct direction is going to walk. So let's see if it's not colliding on the third left, which is here. If this one is not colliding, let's check it. Wait. Back. walk speed. This is a positive walk speed, so it moves this way. So if this one is not colliding, meaning that it moves here, probably to check if there is like a hole. If there is a hole here, it's walking that way. Let's suppose it's walking to the left, and there's a hole. Then it's going to tell the object, no, you need to move the other way. This seems to be the reason why this exists, which the platform detector, the one that actually checks for the platform. So this one check for the holes. For the holes. And this one check for the platforms. For the actual platform. If it's grounded or not. Well, I don't know if it's uses like this grounded. If on wall, that must be a method from character body to the so let's check character body to the and who knows, maybe other bodies have similar methods. Get wall normal is on wall. Where there's the up direction and floor max angle. So there is a floor max angle property, and that's for slopes probably. Maximum angle where there is a slope still considered a floor or a ceiling rather than a wall. And anything beyond that angle then is a wall. Okay, so that's one of the improvements of character body 2D. That wasn't the case of kinematic body 2D in 3.5. I think I could be wrong. I'm pretty sure this is new. So we have the method for checking if there's a wall, and it just flips the character. Changes the speed. It changes the speed. There is some of the slide. And here's how you flip the character. If the speed is more than 0, it's looking to the right, and you scale in the negatives for when it's moving under 0 on the x-axis. That's a very simple way of doing it. Bar animation equals new animation, of course. Now here's the animation. Animation, play, animation. And here's how you go through the different animations. Using the get new animation. So let's go to destroy first. Function destroy void state equals state dead velocity. Okay. So let's see the animations. So this is the function that is used here. Animation new. If state is walking, animation new equals okay. Okay, I see. So if when this is called, if velocity is 0, it goes into idle. So there is an idle animation for the enemy. I didn't see it. Else walk, and that is if the state is walking. Else animation new equals destroy. Return animation new. So it's either walking, and if it's not walking, it dies. Pretty much this is what I'm interpreting here. Alright? If it's not walking, then it dies. So there is not a state for idle. Right, because there are only two states, walking and dead. Okay, so we have then the enemy 2D here. So let's go finally to the player and see how does it work? How does the player work? Obviously, it uses a character, body to the end. Probably the movement is based on the basic template. Of course, it's much more involved than that. But so there's a signal for the coin collected. Right. That signal was part of the coin. Here it is. Okay, so on the body enter, body as player, coin collected, emit. So here is where you send the coin collected emit to the player, which is here. This signal. Let me see something. Let me see something. I'm noticing something here now. So this is for emitting the signal to the player. So how does we specify that is the player the one entering the body? I think is it because of the layers that looks. Let's look at the enemy. Let's get here the enemy. Let's look at the enemy. At the enemy. It does have. And let's look at the coin. I think the trick here is just that the enemy and the coin don't work on the same layer. So this one only works on the first layer, and this one doesn't work on the first layer. So the mask scans for 4 and 5, and it exists on the on 2. Well, the coin doesn't exist on any layer, but it looks on 1, which is where the player. I'm willing to bet that the player is on 1. It's on layer 1, and it scans for every other layer. So that's how it works. That's how it works. It's a layer thing. That's why there's no programming for checking if it's a player or not, because on the coin can only work with the player, with the way that the layers and collision layers are set up. So that's why. That's why I finally got to the conclusion. Something that had me a little bit confused. I'm going to leave the enemy in coin just in case I have to check for them later. So yes, the signal that comes from the coin, when we collect it. So a walk speed and acceleration speed, jump velocity, terminal velocity. Even if it's a constant, obviously, there is a calculation being done, which is why we can modulate the speed using the analog stick. That's something I showed. Let me show you back again. We're going to look, of course, into the. So this is total speed, and this is just a little bit of speed, a little bit of speed. I mean, I'm just using the analog stick, pressing it a little bit, or less speed, a little bit more speed, and then maximum speed. So you can modulate the speed with the analog stick in the way the code is functioning. Of course, if you use the D-pad or the AMD, it goes straight to max speed. I wonder if we can switch. Well. Okay. So we're going to check how the calculation is done. Probably it's very similar to how the character body to the calculation is done, because this behavior is also part of the template that you have when you create a character body 2D. You can use a template, and that template behaves like this. So let's check functions. Physics process. Checking for the floor so that you can get the double jump. So I'm willing to bet that when you use the double jump, here's the double jump. So jump, you can double jump And there's a place where we have to if it's on floor, if double jump charge, try jump. Double jump charge equals false. So the try jump have to be here. Right. So here's where the false speed is. And of course there's the direction. Full speed, move towards. Acceleration speed plus delta. So there is a velocity x and velocity y. So velocity of course is a float. So because it's a float, and that's the thing when using floats, but you technically you could modulate other types of it depends on how high it is. If you have an integer with 100, you can modulate it. But if it's just 0 and 1, of course there will be no modulation. You are either on a 0 or a 1. If it's an integer. But on a float, of course, it could be 1. It could be 0.5. It could be 0. It could be an in-between. Now here's how you flip. And of course you use the move and slide function to move the sprite. I mean the player. And of course there's the get axis. And if it is a part of why the function works the way it is because of get axis. If instead of get axis it will be just get button press, it will be, and you made the function using get button press, but you get back is a boolean, so you're either going to get a nothing or a true. So it will be like, and when true, of course, you apply the speed, it will be straight to back speed, even if you use the stick. But because they use get axis, and get axis works like a float. Get axis. Let's see if we get axis. Let's get diff. It's a float. That's the whole thing of why it behaves the way it is. So it's going to give you a float based on how far you press whatever you're pressing. Of course, if you're pressing a button, it's going to go straight to the maximum value. But if you're with an analog stick, it's going to give you how much you're pressing. Of course, you can always use a different calculation for direction. You could even and we could do a quick let's add if statement here. If, and maybe this is what we should be doing. If direction is higher than 0, direction equals 1. And then we repeat the same instruction again, but now it's looking for and this may work. And then direction equals and now we apply. I don't know if this is me speedballing code here. Oh yeah. Yep, it goes straight to max speed. Now I cannot modulate. I can no longer modulate. I can no longer modulate. I can no longer modulate. So now the behavior is more of what you expect of a 2D, traditional 2D, because in most traditional 2D games you expect, you know, 1 speed, 4. Running, maybe there is a higher speed like when you hold B with Mario, but there's not usually analog input for the speed. Sometimes I guess there is. That was the case actually with Phenom Overdrive, which if you don't know, that's the game I have on Steam. You can check it out. Shameless advertising. But yeah, it uses actually analog controls on a 2D game, but it's not like a 2D platformer. It's more like a, well, it's not a twin stick shooter, but in terms of movement, it's similar. With some twin stick shooters, I think you can also modulate speed. I will have to check if that was the case, but yeah. Anyway, back to this one. But let's go back. Shall we leave the speed like this? You know what? I'm going to leave the speed like this. So that is consistent regardless of which input you're using. And there you go. So let's go. Right, here's where you flip the sprite. Floor, of course, you apply the movement to the player, to the character body, to the. Let's check what it says, because that's the same function you also use for kinematic body to the. But now it's a character body to the. They are mainly used to provide high-level API to move objects with wall and slope detection. That's why it was move and slide. So that you can move around, but also check for the slopes and the walls. I see. It seems like other physics body have the move and collide. Okay, so let's go back to that. Sure, if equals false, of course. If input, okay. If input is action just pressed, and that's the one I say that could have been used here instead of get access, so that you get an on-off switch, and just if it's true, then you add the because the calculation to get the speed is just multiplying the direction by that was it. This is like the calculation. You calculate how much they are pressing the axis and then the max speed. But with this, it's just 1 multiplied by walk speed. So all you can do is just press, and if it's true, then you just go to the walk speed, because the speed just velocity equals speed. Yeah, when you think about that, if it uses this function, the direction calculation, it may be redundant because you don't even use direction to check for flipping the sprite. You just use the velocity itself to check for where it's moving so that you flip the sprite. Oh well. Anyway. And of course, it's a on-off function. So if it's on, it shoots and it uses the gun. So there is a gun. There is a gun function here. So where is the gun? Gun get node. Gun as gun. So there is a node called gun. Is it here? Oh, here it is. So it's not a scene that you are saving. It's just part of the player scene, but it has its own functions. So yes, the gun should. So let's check the gun. Now I have, this is too clutter. There is too much clutter here. Let's close all of this except gun and player, which are the ones that we're checking here. So gun. There's a constant for a bullet. Velocity, of course, the preload for spawning the bullet. And there's a timer too, probably, to check between the time you can shoot bullets. So let's see. Right. Right. So there is a timer. So the function shoot. If the timer hasn't stopped, if it's still going down, the return false. So you don't get any of this happening. So If it's not stop, if it's running, no, if it's stopped, then the bullet is instanced bullet global position equals global position at the global position of player because of the gun, not of the gun, because the gun is the one that is spawning. So the global position of the gun is this one. This is, you could say, self dot global position is the global position of the gun, but that's unnecessary. Bullet global position equals. Remember that I'm a noob. I'm not a pro programmer, so my level of programming has to be like kindergarten programming. That's why I love Kids Can Code. That's the best programming teacher. And sometimes even them, they're a little bit too complex for me to follow them. But hey, whatever. I'll just keep banging my head to the wall. And eventually the code will magically work. So yeah, bullet dot linear velocity posa. And when it spawns, of course, we're using direction. Where is the direction here? It's direct. Oh, okay. Here it is. Here it is. So here's where we declare the direction variable. Okay. Set top level equals true. A child. So I think that setup. I think this is a new function. I wonder what does it mean set as top level. I have never seen this function in 3.5. Maybe it's that when it spawns or is associate the bullet, it puts it at the top level. That's my guess. I really don't know what this is. A child bullet. Of course, here's where we add the child, where the child actually appears on the scene. It's a child of gun. Sound should dot play. We play the sound and the timer starts so that you cannot shoot immediately after. You have to now wait because it will keep returning false until this timer gets to 0. And of course that timer is the cooldown timer, which is here. So it's the cooldown timer for the gun. Okay, so yeah. Let's go back to the player. Did I make a change? Here's the shooting animation. So that is probably just for, rising the gun when it shoots. Let's see it. Interestingly, I wonder if the animation is only applied to the top part, because the running animation is still running. It just shoots. So I'm going to check the animation player to see how those animation works. So here's how it deals with animations when it's on the ground, when it's on the floor. And then here is the one when it's if okay, so here are the ones when it's on the floor, and here's are the ones when it's on the air. However, the shooting is the same animation regardless. So it's the shooting animation seems to be an animation that is specific to that top part of either the top part of the body or just the arm. So that's all it changes. So you can have the running animation running at the same time as the shooting animation, and they do not conflict with each other. So let's look. Well, the try jump, of course, is the one that has the double jump and that sort of stuff. If it's on the floor, it applies the jump. If it's on the air and it jumps, then the first thing it does, and that's something I noticed. I didn't know if I said it, but it seems to add a little bit of speed. And it's a multiplier. So if you have zero speed, it doesn't propel you forward or backwards. But if you're moving forward or backwards, it multiplies the speed by more than twice. And that was something that was very, very. When you actually play it, you notice it. I think I can make it very noticeable by using an extremely high, like this one. So I'm not doing it yet. There you go. You see that? When I apply the second jump, it applies that super speed. Because it's applying the speed, for some reason it's applying the speed to the second jump. So if, like I said, it was more like a dash. It worked like a dash. This is what I meant when I said that it worked like a dash. Because it seemed to add speed. It changed a bit the speed scale of the pitch scale. That's probably why it's a whip. Let's see how it sounds normally. No, that's a. But I changed the scale a little bit, maybe to make it sound so that you know that it's a double jump. It changes the sound. Velocity y equals jump velocity. Of course, you add the actual jump velocity and play the sound. So let's check that second jump again. Yeah. So the first jump is like a bonk. The second one is like a whip. Whoop. Whip. So if you're in the air, when you jump, it goes a whip. And then you turn close to the side. So that's interesting because on the slope, if you jump forward, it's one jump. But if you are moving, it goes straight. Okay. Sometimes it goes, maybe it's moving too fast. Maybe the speed is too fast because it jumps, it does the air jump. I don't know if the sound is so decent. Yes, I can jump a second time. I can jump, if I jump up, I can jump a second time, but well, that's a quirk from the level, and on slopes, you're probably not going to get that second jump. Most probably. Because it goes straight to the second jump. But you get the speed. So maybe it's an intended it's an intended mechanic, like if you are slow. Oh my god, what is happening? Did I change the way it works? It is stuck on the wall. I think I changed the way it works. And now it's stuck on the wall. Poor enemy. Poor enemy. My bad. Let's check the enemy. What change did I make? If it didn't make a change, it should be. Why is it not flipping? Why is it not flipping? What the heck is happening with the enemy? You should flip on that slope. Well, well, well. Well, 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 well. Well, 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 is this? There should not be any problem here. You're just negating. Maybe. You know what? Well, speed is a constant. Is this calculation is fine. This calculation is fine. This calculation is fine. It should flip. Does it have to do with? If this works, I mean, it should not have anything to do with how it hits the wall. I mean, that's merely oh my god, it worked. It worked. Well, I guess that, yeah, the only function that flips the enemy is the one that has to do with the floor detection. Floor detector right and floor detector left. So these are the only ones that are properly flipping the enemy. This one, honestly, I don't know if it's doing anything. Are you doing anything, really? Is that somehow the speed, the oh well, actually, you do something. You actually do something. You actually do something. You actually do something. I am really stumped here. There's probably an oversight somewhere here. Because pretty much then, what you're looking for, if it's not colliding, if it's looking for not colliding, what is then happening is when the wall comes, when it hits at around here, because this is a little bit farther from where the wall stop, you can see that down, if you look at the level here, right, the arrow will be around here. And there is nothing here to collide with. Here, if the arrow was here, it will collide with this. That's why it's flipping. So now that should not be the solution. I mean, it seems to work as a solution, but it should not be. When it hits the wall, it should go into the negatives. So why isn't it doing it? Why is this not working? Is it not hitting the wall? Why is it stopping? If it does it meant to stop? Is that how the demonstration worked? The demo works. It was meant to stop. Is that why? Is it? Is it because of that? But it should not, because here it clearly states that velocity x equals negative velocity. So if it's 1, then it's negative 1. If it's negative 1, then it's 1. Why? And this should work regardless of this. I mean, maybe it's bugged. I'll guess I'll just go forward with everything else. Because I'm stuck here and I really don't know the answer. I don't know if it's a bug with the function or if there is, and no matter how much I look at it, no matter, what do you do? Are you the one causing the trouble here? Let's go back to the enemy, right? It was 15, I think. 15 and 15. Okay. So let's go back. 15:15 a.m. Well. Well. Are you sure you do anything? You know what? You know what, maybe? This is a function. This is not a function. But okay. Well. Oops. I'm so sorry. Let me... What will you do? What will you do? Oh, now you're working properly. Which means that was a fusion. Like that calculation pretty much said if you hit a wall or something, or if you get to 0, Then your speed was equal to the default speed, but I don't think it did properly hit it. Like it didn't properly work. It is now working properly, I think, or what I will expect it to work. So let's copy paste. This is the new function. The new instruction. But that is the old instruction. Let's write the new instruction. This wasn't working appropriately. I think this is the problem. This has to be the problem. Is this working the way it's supposed to work? So very much what it comes down to is that the enemy stopped. With this one, the enemy stops if it hits an obstacle. With this one, it actually flipping is actually flipping because this function it forces it to move even if it's not moving. But this function it seems to be fine if it's 0. If it's 0, 0, it does nothing. Fine. So you have to be a little bit more than 0 for the walk speed to apply. Is it to make sure that I don't know. I completely stopped here. But yeah, that will be a change I will make to that. Yeah, well, I guess kids can code. Here I come. Because that will be a change I will make then. So let's finish up then with the enemy. And let's go into to finish up with this demo. Let's go with the pause screen. And this is pretty much mostly UI stuff. Even the quick code is part of the pause screen. Let's see. So normally you see your coins, but yeah, when you pause, you see your coins. So that's why the coins is part of the that leaves it clean. That leaves it clean. So I'm going to bet that the color rect is that thing over here. Yeah. There you go, better. Now, when I pause, I prefer that. It looks cleaner. Now the game paused. Well, it doesn't look. It can melt with the. It is not that important. That is not that important. Game pause. Okay, let's go to visibility. Yeah, let's add some contrast. Maybe some. I think it looks nice here. But still. Okay, let's try yellow. Maybe a stronger set of yellow. Okay, let's go back to whatever. I guess we can add a little bit of dark. There you go. That's all the darkness you're getting. That's you're pretty much making no difference. I guess I could get maybe 24. Now you're making a difference. Now it's making a difference. But it's very slight. Good. I like subtle. I love subtle. There you go. Oh yeah, this one is much clearer. I think I'm going to let it stay at 32. That's more that anyone can notice that. There you. So yeah, color Rex for the background of the boss screen. This is the background of the boss screen. Okay, so it keeps things centered. This one is probably anchor to the top left. I'm going to guess. I see. So there are three buttons with signals. And the signal goes to the pause menu. However, an interesting thing is that the coins counter have a script and they are its own node. So why? Obviously there's an animated sprite, that's fine. Of course there's a label. I call it a label, it's a label. It's a script to keep with the coins and how many coins have you collected, yeah. So the coins counter keeps count of the coins. So let's check the pause menu of the there's a fade in and a fade out. I never did this. I just instantly stop and instantly. But well, I don't think this is probably for a stop. That's probably just for the color rect. Uh-huh. I'm going to add these two buttons. Just send signal. Yeah, they just sent signals here. Quit, split screen, resume. So the quit button is something that was added. So that is one scene that has the pause menu plus the split screen button. Which one is the one that is adding? Yeah, it's adding the split screen button. And then there's the pause menu. Of course, if you press this one, which is without the well, makes you wonder. It makes you wonder. I mean, it's not necessarily something that is right or wrong to just make a whole new scene for just one option, but hey. Of course, what I'm going to guess happens. Let's see if there's a pause menu. Split screen. There is a pause menu split screen, and the difference is going to be that particular. So you have one pause menu for the single player, one pause menu for the split screen. It's going to be that button, the difference. However, when you look at here, of course, it has all the functions. Of course, because this is the single player one. But if I were to oh well, whatever. Oh well. So that's the change. Now you could have gotten the same functionality, I don't know, using booleans. One boolean for single player, one boolean for multiplayer, and then you check one boolean, check if it's false or true, and you put the single player. Actually, you could use just one boolean called single player. And if single player is true, it behaves in one way. If it's false, it behaves in the other. Why not just use that? One boolean like here. Bar and what the button, that button, this one, change to single player does is that it change to multiplayer or change to single player. It change the boolean, and depending on the boolean, what if you're going to be multiplayer or in split screen, and of course the boolean not only changes the split screen and the single player, but also changes the text. So that when you are a single player, it says change to split screen, and when you are split screen, it says change to. You can do that. I don't get why you're using two scenes. You don't need two scenes for this. What? Hey, different people have different ways of doing it. It's not a way of doing it. Maybe split screen was an afterthought, and they just. I mean, this is an easy way of doing it, I guess. Beady. What's a beady? Okay. So most of the other is just, where is everything going to go? There's a grab focus, so when it's open, it will focus on the resume button. It can easily be seen, especially if you're with a controller. You can see that the focus is on the, because it's of the outline. If I change the focus with the mouse, well, actually, that's a highlight. That's not a focus, that's a highlight. So if I change the focus by using the D-pad, now resume is no longer focused. Okay, so by default, the resume button is the one that is focused. And the fade in is at when. And that's when you pause and unpause, isn't it? Let's see. Pause and unpause. So there's a transition. It's easier to see if I'll go back to the color rect, because it's much darker now. You can see that it doesn't get instantly dark, but it fades. So that's what it functions. That's why there's a twin to interpolate between the alpha, the transparency, the alpha. Using the duration that we set here. And of course, when you close, there's also the hide. It calls the hide function. Hide is just this. That's our built-in function for control to hide. I think we found it. Well, anyway. So yeah, I guess that's a simple look at the pause menu, which was the final thing. We will look how it works. And like I say, this is a much more involved, more advanced demo. I might take another look and maybe change a few things. Because in order to make it work how I expected, right, I had to make a few changes, especially to the enemy. Which makes me wonder, if that is the way it was supposed to be. Which could be, maybe if the enemy hits an obstacle, it's supposed to stop. That might be it. But well, I guess I'm going to leave it here for now, and maybe I'll think over again and maybe experiment in the future. I could see me doing that, like making a few experiments with the different scripts. But yeah, well, that's it.